Hello, my name is Gerard Baladad, and this is my audiovisual commentary. In this presentation, I will first give a short introduction to the project. I will then provide a critical analysis of the specialist techniques used. Next is a discussion regarding the interplay between audio programming and the sound design process, followed by an evaluation of the project outcomes and conclusions. Lastly, I will briefly show any references used. This audiovisual commentary presentation is for the Audio for Games module, which is a Level 6 course of the BA Honors Music Production and Sound Engineering degree at Point Blank Music School in collaboration with Middlesex University. Here, I will discuss, critically analyze, and reflect on the specialist techniques used for the practical assignment to create and implement music and sound effects for the Innerspace game. I will demonstrate my creative and technical practices and discuss theories and concepts that influence the project's game audio development. Innerspace is a first-person shooter game that contains a level with enemies such as minions and a boss, a selection of weapons, keys and doors, pickups, and a variety of rooms and surfaces, and challenges to progress from beginning to end. The music was produced in Ableton, and all the sounds were layered and implemented through FMOD. The game is designed for both kids and adults and is fairly easy to play, considering that it is not possible to die during gameplay. Ableton Live 11 is my chosen DAW for recording and editing audio for Foley and sound design, and I used a variety of microphones. For example, I used the Warm Audio 49 Junior condenser microphone to record the wet footsteps with a wet floor mat, as it sounded very similar to walking on wet flesh. For submerged footsteps, I used an iPhone microphone to record while at the beach. Once I had all the raw audio, I removed a bit of noise and rumble with Isotope RX and edited them into individual clips and tracks to make them easier to export all at once. Some sounds were made through synthesis. I did wavetable synthesis for the UI sounds using Native Instruments Massive X for the digital layer and Massive for the blip layer. The positive UI sound is an ascending C major 7th chord, and the negative UI sound is a descending C minor 7th chord. A study by Leigh Flores et al. 2022 proved that ascending notes psychologically invoke faster movements and create motivation to do a task than descending notes. This influenced the creation of my UI sounds. Proper layering of multiple sounds was crucial to syncing the audio with visual elements, and it required millisecond precision to do this. For example, the Hilomatic 500 gunfire sound comprises layers of a pitch-shifted closing microwave door, pitch-shifted bubbles, a short mechanical layer, guitar clunks, real gunfire, low impacts, and a laser splash. After experimenting with different positions for each layer, I have chosen this because all the sonic elements blended well with each other, forming a very convincing sci-fi weapon sound. For non-linear composition, I first created an adaptive music flowchart for the game. It shows that the game level needs 8 pieces of music, 1 pre-roll music, 5 music loops of varying intensity and emotion, 1 transition loop, and 1 key layer. After playing through the whole game multiple times, I found that it needs to have mildly suspenseful music with a humorous mood because the game is for all ages. 120 BPM music. Caprito 2021 mentions steady-state cardio such as jogging is between 120 to 140 BPM. This tempo feels natural in relation to the player's gameplay movement speed. All music except victory music is in the key of C minor, C major key victory music. This was influenced by a study by UNG 2017, which shows that major chords give emotions such as satisfied, peaceful, happy, and pleased, while minor chords give emotions related to unlively, depressed, disheartened, and calm. As you can see, each loop is exactly 16 bars and contains funk and rock instruments such as drums, electric guitars, and synthesizers, as well as Latin percussions like egg shakers, cowbells, güiro, shekere, and clave. All instruments except the egg shaker were programmed with MIDI because it allowed me to make any changes to the notes, velocities, and automation during and after recording. I utilized vertical and horizontal transitioning techniques to launch my music loops so that each music clip is appropriate for each situation and would transition according to how the gameplay develops. I went with the horizontal transitioning approach for transitioning music because the game level is fairly short and the 16-bar music loops already contain variation in the composition. I created a discrete parameter sheet called music progression with a range from 0 to 4 to cover the 5 16-bar music loops, excluding the key layer. To seamlessly transition between each loop, I used loop regions, transition regions set with a 1-bar quantization interval, and a magnet region set with a quarter note quantization interval for the victory music loop at the end. However, I went with the vertical transitioning approach for the 16-bar key layer because it only plays when the player has the key and before each door gets opened. To play it in sync with the music, I imported the key layer loop to each loop region in the main timeline and created a continuous parameter sheet called key layer with a range from 0 to 1. As shown in the volume fader automation, 0 means the player is not in possession of the key, so it is set to -infinity dB to mute the key layer, and 1, which means the player is in possession of the key, is set to 0 dB to play the key layer at full volume. The 6 speed is set to 1.7 per second for a smooth transition. Lastly, I added my 1-bar transition loop to all transition regions that need it. This made the transitions very musical and signifies that the player has entered a different area in the gameplay. In Unity, I added 2 box colliders as triggers, one for each door entrance and exit, and used 2 FMOD local parameter triggers, one for trigger enter and one for trigger exit on each collider. This method seamlessly transitioned my music as the player moves around the level. My mix for the game features 8 techniques done in a specific order: mixer window organization, live update setup, volume balancing, sidechain compression, optimization, snapshot creation for reverb, delay, and UI low-pass filter, profiler session recording, and loudness adjustment. I first organized the FMOD mixer by routing events by groups. This is to have a smooth and functional workflow for the game. To have even more control, I created mixer views for actions, ambience, enemies, music, player, UI, and weapons. I then enabled the live update function to implement and monitor mix changes in real time. To balance the volume levels, I referenced the game audio hierarchy pyramid to know what sounds to prioritize over others. This greatly reduced clashing of sounds and improved clarity in the dialogue and sound effects over music and ambience. However, I noticed that the weapons clash with the music despite the music being lower in volume. To fix this, I did sidechain compression to duck the music whenever the weapon sounds are triggered. This further reduced clashing and prevented distortion. Optimization is another technique used to limit the number of instances for a sound. This was set in the enemy idle sounds and the rifle gunfire sounds, and it proved to be effective in saving valuable headroom in the mix. I proceeded to create snapshots to store mix changes for specific game scenarios. All the spacious rooms trigger snapshots that have increased reverb and delay to replicate the acoustic properties of a wet and closed environment. The UI pause window also triggers a snapshot that filters all the sounds to create a sense of disconnection when the game is paused. Lastly, I recorded an FMOD profiler session of the entire gameplay. This was used to further refine any mix changes, and when replayed in full, is also used to set the loudness to the target of -20.5 LUFS plus or minus 5 dB, which is in between the industry recommendation of -23 and -18 LUFS, Menhorn 2013, through the use of a submix VCA fader, limiter, and loudness meter. I wanted all the sounds to be convincing and natural when accompanied by the visual elements in the game. FMOD made this possible through features such as 3D spatialization, randomization, probability, modulation, and parameter sheets. I extensively used FMOD's 3D spatializers and adjusted its settings to correctly position sounds and model real-life acoustic settings. A curve distance attenuation was used because sound pressure levels are generally expressed logarithmically. Minimum maximum distance, envelopment, sound size, and minimum extent were adjusted according to the size of the object and its placement within the room. Using randomization combined with modulation and probability conditions significantly adds to the realism of sounds. Harris 2010 mentions that the use of randomization can preserve player interest across multiple playthroughs. This is why on the enemy sounds, using the Slimer Idol event as an example, the laugh track had 2 different laughs on a multi-instrument, along with pitch modulation and a 50% probability, all of which prevent repetition. Lastly, parameter sheets made it possible to have adaptive changes to a sound depending on where the player moves in the game level. On the footsteps, for example, I recorded, edited, and imported 3 types of footsteps for 3 surfaces present in the game: wet, submerged, and bone. By creating a discrete parameter sheet called surface and assigning a footstep type with a parameter value to be set in Unity, the footsteps adaptively change according to the surface the player is walking on. All the amazing sounds created for the game would have been worthless if not properly implemented into the game. I envisioned a smooth and seamless gameplay experience for the player, and FMOD in Unity made it easy to implement audio without actually programming with scripts. Unity's FMOD event emitters, local and global parameter triggers, and colliders allowed me to use all my audio within a 2D and 3D environment. FMOD Studio event emitters within Unity has played a key role in the game, as these enabled me to place sounds in specific locations or objects. For example, I used these for the brain room. Emitters were used to emit monster death, idle, pain sounds, and electrical brain sounds. As these emitted 3D events, their volume is dependent on the distance between the player and the FMOD event emitter. The game required a great deal of detail and adaptability. FMOD's parameters and Unity's parameter triggers work in tandem to adaptively change the audio in certain conditions or situations. For example, the key layer only plays in the condition that all enemies are killed in a zone. This was made possible by adding 2 FMOD global parameter triggers on the brain room key with the main music emitter event selected. One parameter trigger is for object enable and another for object disable. For music, my vision was to have music changes whenever a door gets unlocked and whenever the player passes through each door entrance and exit. To do this, box colliders were used as triggers for the FMOD parameter triggers that determine which music loop will play. This project is successful because it was carefully planned, well implemented, and featured specialist techniques such as recording and editing of assets, interactive sound design, layering, nonlinear composition, vertical and horizontal transitioning, and mixing. It also showed extensive use of FMOD features such as 3D spatialization, randomization, probability, modulation, and parameters, as well as Unity features such as FMOD Studio event emitters, FMOD Studio parameter triggers, local and global, and colliders. However, the beginning was challenging for me because I was new to the game audio development process and concepts, so it involved a lot of trial and error and familiarization with the layouts of FMOD and Unity. This resulted in a lot of revisions and experimentation both creatively and technically. But looking back, I have gained a broad understanding of game development and a deep understanding of how audio and music for games are created and implemented. I learned that having a clear and defined vision is crucial in order to be successful in the world of games. If I were to be given another task of making game audio and music, I'm going to suggest that I improve my project management skills, as it proved to be very important, especially in larger projects where time is of the essence.